Okay. Only 4 more days. I hate to say I told you so, but I told you so. This semester really went by fast. Okay, we're going to review. Excuse me. Well, yeah. We're going to review a little bit of what we did the other day with exponents. Remember, if we have squared times a to the fifth, remember when we're multiplying and we have the same base number, the one on the bottom, the big number, is the base number. If we're multiplying and we have the same base number, we add the exponent, so it would be a to the 7th. Now, if we're dividing, if we have a to the 5th divided by a cubed, what we do here is we subtract the exponents. Here, if we're multiplying, we add them. If we're dividing, we subtract. So that would be a squared. Now, if you have, one thing you're going to have to remember is if you have any number to the 0 power, you think would be 0, right? Well, it's not. It's 1. You're going to have to remember this. This is the reason for this. If you have x to the 5th divided by x to the 5th, what's any number divided by itself? 1. Right. Or we can say it's x to the 5th minus 5 minus 5 is 0, so that's x to the 0 power. I hope that makes sense. You're going to just have to remember this because when you first look at it, you think that it's 0. Well, it's not. The number to the 0 power is 1. Okay, now what you're going to get on the final exam is it's going to say evaluate with all positive exponents. All positive exponents. Now, if the exponent's negative, move it. If it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. You just have to move it. So if you have c to the negative 3 over e to the minus 5, look, take these one at a time. They're really very simple. But you look at it and think, oh my God, I can't do this. Pull the fraction bar and take them one at a time. C to the minus 3, where does it go? To the bottom. And the exponent becomes positive. E to the minus 5, go to the top. And again, the exponent becomes positive. Okay. And what do we have here? Now, if you have this, you have r to the 3rd divided by r to the negative 2nd. Again, take these one at a time. Call the fraction bar. R to the 3rd, that's already positive, so it stays where it is. That's r to the 3rd. Now, r to the minus 2 goes to the top and becomes positive. What's in the denominator? 1. You don't have to write that because it really doesn't mean anything. Remember, now, excuse me, now we have two numbers with the same base number. So what do we do with the exponents? We add them. So that's r to the 5th. They get a little longer than this, but they really don't get any more difficult. It's just the same thing. Now, if we have this, let's see. Like I said, these numbers, they really don't get any more difficult. They just get longer. So if we have 7x to the minus 3. Before I forget, what's the exponent on 7 here? 1. Positive 1. Don't forget that's a separate number. And y squared. Can we do anything here? No, because the base numbers are different. Divided by 2 to the minus 1 x squared y to the minus 5. Like I said, these things, they really don't get any more difficult. They just get longer. So take them, draw a fraction bar, but take them one at a time. Where does 7 go? Stays at the top because the exponent there's 1. X to the minus 3 goes to the bottom, and the exponent becomes positive. Y squared stays on the top in the numerator because it's already positive. Now 2 to the minus 1, it goes to the top and becomes positive. X squared stays on the bottom because the exponent is positive. And y to the minus 5 goes to the top. Now we have to clean all this misery up. What can we do here? First of all, we can multiply 7 times 2, I think it's 14. By y squared and y to the 5th, they have the same base numbers. So we can add the exponents. Y to the... Everybody with me here? Am I going too fast? Okay? Okay. Over. And again, we have the same base numbers here. It's x to the 5th. That's all there is to it. It's really very simple. It just takes several steps to do it. But just take them one at a time and do what you can do. Let me take a drink of your Diet Coke. Mm-hmm. Mm-hmm. Now what if you have this? A squared over b cubed, all raised to, this is the power rule. This one where you added the exponents, that's called the product rule. If you have, let's say, to the power. When you have a power raised to a power, you multiply the exponents. This is going to be a to the 10th, right? 2 times 5 over b to the, what is it, 15? Okay, is there anything we can do there? No, because the base numbers are different. When you have, again, when you have a power raised to a power, when you have an exponent raised to an exponent, you multiply the exponents. And remember, the parenthesis makes this one number. So what if we have, get this if you're so smart. Let's see. Got this one. Sorry to cram all this together like this. I have a real personal problem with wasting paper. I don't know what it is. We have a to the 4th. Excuse me. B to the minus 2 over b to the minus 2 a to the minus 5. All raised to the negative 3, negative third power. Right? Again, take them one at a time. A to the 4th. Remember, we're going to multiply the exponents. So 4 times negative 3 is negative 12. Positive times a negative is a negative. And then b to the negative 2. Negative 2 times negative 3 is a positive 6. Think. Again, b to the negative 2 times negative 3 is b to the 6. Now look, you've got the same numbers here and here. So we can just cancel those out because any number divided by itself is 1. We go a to the -5 times -3 is a positive 15. What did I do here? That's right. Right. This equals, again, draw the fraction bar. Look, again, we can eliminate these two because 6 minus 6 is 0. When we divide fractions, we subtract the exponents. 6 minus 6 is 0 or 1. Or you can think of it as any number divided by itself is 1. We have a to the minus 12 goes to the bottom, becomes positive. A to the 15 is positive, so it stays there. What's in the numerator? 1. We must have the 1 in the numerator. Now here we have two numbers with the same base number. They're both a. So what do we do with the exponents? We add them. It's a to the, 27? Okay. This is about as difficult as they get, and it's really not all that hard. Okay. Had enough of exponents. That's fun stuff, huh? I don't think so. Now you're going to get a polynomial. Poly just means many. Nomial just means numbers. Let me go over this real quick. If we have 3x, that is a monomial, M-O-N-O-M-I-A-L. Mono meaning one. This is one number. And if we have 3x plus 2, this is two numbers. So this is a binomial, N-O-M-I-A-L. If you have three numbers, a trinomial, and it's fun. Say 3a squared plus 2b minus 6. Three numbers, right? When they're separated by a plus or a minus, makes it a separate number. This is a tri. Tri meaning three, like a tricycle or whatever. Tri, N-O. Please stop me if I'm going too fast or you don't understand something. Please stop. Stop me. Okay. So, what if we have negative 5b plus b? Are these like terms? We talked about this, I don't know, a couple of weeks ago, it seems like. If we have the same variable and the same exponent, they have to have the same exponent also. This is nothing more than addition, subtraction. So this is 8 minus 5 or 3. Right. Okay. You're going to get a thing that says evaluate, E-V-A-L-U-A-T-E. Evaluate means just find the value of. If you have 3x squared plus 5x minus 10. Trinomial. Super whiz-bang important, but you are going to see that these terms from time to time. And you look at this and you think, what the hell is this talking about? That's real simple. What they're saying is let x be 2. Okay, so we have 3 times 2 squared, right? We put a 2 in here. Wherever there's an X, we're going to plug in 2. 5 times 2 minus 10. I'll give you a little hint here. You can put that, but please don't tell on me. I'm in enough trouble as it is. Excuse me. You can plug this into your calculator just like this. 3 times 2 squared plus 5 times 2 minus 10. And it will. This is just a order of operation. Probably the most used thing we do. Okay, first do we have any parentheses? Yes, but there's nothing to do in there. Is there an exponent? Yes, there is. So it's 3 times 2 squared is 4. Plus 5 times 2 is 10. Minus 10. 10 minus 10 is 0, so that's basically gone. And we have, this is 12. Right. Okay. Let's do the same thing. We take this trinomial, or x equals -3. This is where you have to be careful, these godless negative numbers. Okay, so we have 3 times -3 squared plus 5 times -3 minus 10. Again, order of operation is -3 times -3, which is a +9. So we have, right? And again, if you're not sure, plug it in your calculator. Again, don't tell on me. 5 times -3, a positive times a negative is a negative. Is that 15? Minus 10. 3 times 9. Order of operation again. We do this first. That's 27. -15 minus 10 is a -25. So this equals 27 minus 25 is 2. That's all there is to it. It's really very simple. And again, you can use your calculator and it'll do order of operation for you. Okay, now what if we have kind of shift gears here a little bit? If we have 5a minus 2 minus 3a minus 8, 3a minus 4. Okay. Again, PEMDAS. Do we have parentheses? Yes, but there's nothing to do in here because they're not like terms. Do we have multiplication division? Yes. This actually means -1 times all this over here. So this is 5a minus 2. Now, what is the -1 when you multiply it? Here, what does it do? It just changes all the signs. It doesn't really do anything else. A negative times a positive is a negative, so it's minus 3a. Negative times a negative is a positive 8. You're going to see this on the final. Probably going to be a little bit longer than this, but basically the same problem. Okay, now we combine like terms. 5a, -3a, -2, and a positive. 5a minus 3a, this is 5 minus 3 is 2. 2a, and 8 minus 2 is, was it 6? Plus 6. Okay, am I going too fast? Please tell me if I'm going too fast. Okay, this is real simple. It takes into account a lot of the things that we've done already this year. Okay. It's cold in here. I hate the cold weather. To be a hater, but I'm hating on cold weather. Okay, get this if you're so smart. 4x, open parenthesis, 3x plus 2. Did this a little bit a few weeks ago. Remember, the parenthesis makes this one number. So we're going to multiply the negative 4x. Negative 4x. We're going to multiply the 4x times everything inside the parenthesis. Super duper whiz bang important. Now, 4x times 3x, 4 times 3 is 12. Remember, x times x is x squared. Right? Right. Because remember, the exponents there are 1. We just don't write it. And 4x times 2 is positive 8x. Can we combine these two things? No. Not like terms. Remember, the base numbers have to be the same, which they are, and the exponents have to be the same. So, different deal. This is the distributive property of multiplication. I hit the record button. Yes, I did. How about that? Okay. Very, 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 very important. Okay, and if we have this, we have 3a squared, open parenthesis, 4a minus 5. Again, distributive property of multiplication, very, very important. We're going to take the 3a squared. This is a term, and we're going to multiply all the terms inside. Now, 3 times 4 is 12. A squared times a, remember, with the same numbers, so we add the exponents. It's going to be a cubed. And then 3a squared times a negative 5, a positive times a negative is a negative, excuse me, negative 15a squared. Okay? Can we combine these two things? No. The base numbers are the same, but the exponents are different. Right? Right. Okay. Now these problems, they don't get any more difficult, they just get longer. And here's a prime example. 2a cubed times 5a squared plus 7b minus 3. Okay, we're going to multiply the 2a cubed times everything inside here. 2a cubed times 5a squared is, well, first of all, 2 times 5 is 10. A cubed times a squared. Same base number, so we add the exponents. Was that 5? Now 2a times 7b is 14. A cubed b. Cannot multiply a times b, so you just write it just like that. And then 2a cubed times a negative 3 is a negative 6a cubed. Are there any like terms here? No. You cannot add this, even though this is a cubed and this is a cubed. It's not the same deal. What did I do here? Equal that. I'm sorry. I'll do better. No, I'm not going to do any better. I'm sorry. Did everybody see this? This is 2a cubed times 7b is 14, positive 14, a cubed b. I'm sorry. I'll do better. No, I'm not going to do any better. My wife would tell you, well, he's just stupid. Yeah, I know. Mm-hmm. Okay. This is super duper whiz bang important. We have 2x plus 3 times 3x plus 4. Now, what the hell are we going to do here? Same stupid thing. The only thing is it's a little bit longer. Look, take these one at a time. Take this one, the 2x, multiply it times everything over here. 2x times that, 2x times that. Then take the 3, multiply it times everything over here. This looks difficult. It's not. Very, very important. 2x times 3x. I'll put my finger on here so I don't get confused. Okay, 2x times 3x is 6. X squared, remember x times x, you add the exponents. Then 2x times 4 is it 8? 8x. Okay, now we finished distributing the 2x. Now we do the same thing with the 3. 3 times 3x is 9x. 3 times 4 is 12. You'll see the middle two terms are typically common, or the middle two terms are typically like terms. So this is 6x squared. 8x's and 9x's are, I think, 17 plus 12. Very, 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 very important. Okay, let me do another one. 3x plus 2 times 5x minus 4. Same problem, we're multiplying two binomials. Okay, first we take the 3x, multiply it by everything, multiply it times everything over here. Then we take the 2 and multiply it times everything over here. So 3x times 5x is 15x squared. All right? My brain just went numb. 3x times a negative 4, positive times a negative is a negative 12x. Okay, now we finished multiplying this times everything over here. Now we're going to do the same thing with the 2. 2 times 5x is positive 10x. 2 times negative 4 is negative 8. Again, middle two terms are common. We have 15 squared minus 12 plus 10 is a negative 2x minus 8. I go too fast. Don't everybody answer at once. Okay, I got this. This is not going away. You're going to see this forever. Let me ask y'all something. We really should have another test. However, I'm sure y'all are sick of all this. But if we take the last 2 quizzes, 2 or 3 quizzes, take the average of those, make that your test 2 grade. Is everybody okay with that? Garcia, are you okay with that?
Yeah, I'm okay with that.
She's a troublemaker. Mr. Sitta?
Okay with that.
You okay? Mr. Trejo?
Good with that.
Good. Mr. Razzo?
Fine with that.
Okay. Let's see. Mr. Ramos?
Yeah, that's cool.
You okay? Mr. Garcia? He's out smoking a joint or something. You can't say that, and school is inappropriate for the school environment. Mr. Garcia? Oh. Mr. Lambie?
Yeah, go with that.
Okay, Mr. Lambie? Okay. I didn't want another test, did you? Sure. Ms. Garcia says she wants another test.
No, why am I having a test?
I know you're a troublemaker. Don't you give me any of your back talk. Rotten kid. She's a troublemaker. Hey, this is one of those things you want to be on the lookout for. This is called a conjugate. The word is particularly important, but conjugate. Conjugate. Now, what we get when we have a conjugate is if we have a plus 3 times a minus 3. Okay? Same exact term here, except the signs are different. Okay? Excuse me. So let's do order of operation. Distributed property, a times a squared, a times negative 3, negative 3a. We do the 3. 3 times a plus 3a. 3 times negative 3 is negative 9. Now, what do you know about this is called the linear term. The linear terms are opposites of each other. So what happens here? Any number minus itself is 0. This is going to be equal to a squared minus 9. That's what happens when you get a conjugate, and we'll use more of this later. Cold in here. Okay, what do we have here? Conjugate, right? Each expression is the same, except the signs are different. This equals b squared plus 5b negative 5b minus 25. Middle two terms are opposites of each other. This equals b squared minus 25. Everybody okay with this? Okay, be on the lookout for this. These conjugates that will help you later. Okay. Okay. Now, what we're going to see later is when you factor, you're not going to like hearing this word because you're going to hear it over and over and over. What happens if we have well, let's do this first. B minus 6 all squared. Remember, this means to multiply the base number. Now, the base number here is this. Remember, the parenthesis makes this, makes this one number. So what do we have here? B minus 6 times itself. B minus 6. That equals, now we take b and multiply it times everything over here. We'll get b squared minus 6b, right? We do the same thing with the negative 6. Negative 6 times b is negative 6b. Negative 6 times negative 6 is a positive 36. Those two terms are common. Is this a conjugate here? No. Oops, sorry, can y'all see that? And so we get squared. Negative 6b and negative 6b is a negative 12b plus 36. Okay? Now what we're going to do next is we're going to go, it seems like everything we do in math, we do frontwards and backwards. And what we're going to do is we're going to take this expression, we're going to take it back to that. Okay? The procedure is really pretty simple. Excuse me. Okay, first of all, let's say we have this. If we have 3b plus 6, what can we factor out of both of these terms? It has to be both of them. In other words, what can we multiply 3? It doesn't have to be 3. In this case, it is. We factor something out of each one of these terms equally. Yes, we can take a 3 out. 3 times what is 3b? B. 3 times what is 6? 2. Now look, I always do this backwards also, just to make sure I didn't get fouled up here. 3 times b is, now we do it just distributive property. 3 times b is 3b. 3 times 2 is 6. Okay, what about this? If we have 5c plus 15. And again, what can we factor out of? What factor or number is common to both of these? 5. Right, so it's 5 times c. 5 times c is 5c. And 5 times 3 is 15. Now do it backwards also. It only takes a second. 5 times c is 5c. 5 times 3 is 15. So we're correct. How about this? How about 6e plus 3. What number is common to both of these? There's a factor of both. 3. Three times 2e is 6e. 3 times 1 is 3. So we're correct. This if you're so smart. Negative 5a plus 10. What can we factor out of both of these? Negative 5 is going to be times a minus 2. Negative 5 times a is negative 5a. Negative 5 times negative 2 is a positive 10, so we're correct there. Everybody okay with this? This is not, like I said, this is not going away. You're going to see this forever. Okay. 6b squared plus 18b. Okay, what can we factor out of each one of these terms? First of all, 6, right? And we can factor a b out of here also. So 6b times b. 6b times b is 6b squared. And then 6b times stuff here will give you a headache, won't it? Okay. 6b times b is 6b squared. 6b times 3 is 18b. Okay. Take a drink of your Diet Coke. Is everybody okay with this? Like I said, this is not going away. Okay. Now, factoring by grouping. Okay, this is important also. If we have this, if we have A times A plus 3 closed plus 4 times A plus 3. Okay, now these two terms here have to be the same. If they're not, either something's gone wrong or this is not exactly this problem. But if we have this, what is this going to equal? This is going to equal A plus 4. Okay, this and this times A plus 3. We only use one of these, not both of them. Okay, so if we did if we did distributed property here, we would end up with that in a different way. Okay, it's called factoring by grouping. Very, very important also. Let's see. Got this. X squared okay. These two are the same, which we must have. If those are the same, then we can do factoring by grouping. Group this and this. X squared minus 5. Okay, that and that. Times X plus 1. And again, we only use one of these, not both of them. Okay. Now, if we had this, if we had A cubed times A minus 3 minus 2 times A minus 3. Okay. This and this are the same, which we must have, or else there's nothing you can do. So we're going to group this and this. A cubed minus 2 times A minus 3. Right. Group those together, ergo the name factoring by grouping. What would be more fun? Okay. And they really don't get much more difficult than that. They just get longer. Y'all sick of hearing that, huh? Let's see. Okay, what if we have this? Now let's do this one. No, not that one. I don't like that one. What have I done here, stupid boy? Okay, let's do this. They can also be kind of moved around, shifted around a little bit too. If we have 8 opened, 7t plus 4 plus x times 7t a stupid boy plus 4. That's a t there. Okay, 7t plus 4, 7t plus 4. So these are like terms. So we're going to group this and this together. We're going to have 8 plus x, but typically we write it x plus 8 times 7t plus 4. Right. How about this? We are open x minus 1. I'm sorry. 5x minus 1. Sorry. I'll do better. Plus 7 times 5x minus 1. Do we have, are these two terms the same? Yes, they are. So then we can do this. Equal 3r plus 7. Okay. That times of x minus 1. Right? Okay, how about this? 8x squared times y plus 4 closed plus 7 times y minus 4 closed. These two terms the same? No. So this is not factorable. Just get 8x squared times y plus 4 times 4 times y minus 4. It's supposed to be a 7 there. Okay, cannot factor that. That's unfactorable or not factorable form. Okay, let me do one more of these just to, excuse me just a second. Sorry. Okay, one other thing might look a little different, but it's basically the same thing. If we have C open x plus 2 closed minus D open x plus 2. Okay, again, these two are the same. This is really not any different. It just looks a little different. So we group these two together. C minus D times x plus 2. Wait. Same stupid thing. Okay. Let's see. I don't like that. Nope. Okay. Factoring trinomials. And A equals 1. Now, excuse me, what this means is A equals 1. Trinomials are typically in the form ax squared plus bx plus c. Okay, and A here, this number is going to be, when this one is 1, this is the procedure that we use. So if you have this, first of all, let's do this. Let's do x plus 2 times x plus 3. Let's do this, and then we'll go backwards and do it the other way. Again, distributive property, x times x is x squared, x times 3 is 3x. Now we do the 2. 2 times x is plus 2x. 2 times 3 is 6. Middle two terms are typically common. So we get this x squared plus 5x plus 6. Now what we're going to do is we're going to take this and factor it back into these two. The way we do that is actually pretty simple. We take what are the factors of 6? Now what we want to do is, if you'll notice, the middle term is called the linear term, not particularly important. What this is the combination of these two, 2x and 3x. So what are the factors of 6? 1 times 6, 2 times 3, right? And that's all. Which two of these add up to 5? 2 and 3, right? So it's going to be x plus 2, x plus 3. Okay? We take the factors of 6. That's called the constant. We take the factors of the constant and find which two of these add up to the middle term, the linear term. So here we have this is the same as x plus 2, x plus 3. Right? Right. Okay. It's cold in here. Okay. So what do we have here? Let's do this. If we have a squared. This fun stuff, huh? Good stuff. Betrayal is good stuff, huh? Okay, I don't blame you. Plus 9a plus 14. Now, first of all, we want the factors of 14. What are the factors of 14? 1 times 14, 2 times 7, 3, 4, 5, that's all. Which two of these, 1 plus 14, does that equal 9? No. 2 times 2 and 7 is 9. Right, so these are our two factors. So it's going to be a plus 2 times a plus 7. And it doesn't make any difference which one's first. It can also be a plus 7 times a plus 2. Doesn't make any difference. Right. Okay. Love factoring. I haven't figured out why, but they do. Okay, let's see. If the book has anything here that's any fun. Simplifying radicals, that doesn't sound like any fun at all. No, that's no fun. No. Going stupid. Okay. Hold on just a second. Okay, I've got some here. What if we have this? What if we have... No, let's not do that. What if we have x squared plus 4x plus 5? Oh, this is stupid. What are the factors of 5 add up to? What are the factors of 5 that add up to 4? Only one factor because this is a prime number. 1 times 5. Does 1 and 5 equal 4? No. So the answer to this one is prime. In other words, it cannot be factored. What are they doing with all these godless negative numbers? No, no. Well, let's do this. Okay, now that's where everything was a positive number. Now what happens if we put some negative numbers in there? M squared plus M minus 20. Now the procedure's exactly the same. We take negative 20. What are the factors of negative 20? Negative 1 times 20, negative 2 times 10, negative 4 times 5, and that's all. It's also be the opposite. 1 times negative 20, 2 times negative 10, and 4 times negative 5. Now, which two of these add up to? Now, what's the coefficient, the number in front of m? 1. Now, which two of these? 20 minus 1 is 19. That's not it. 10 minus 2 is 8. That's not it. 5 minus 4. 5 minus 4 is positive 1. So we get this. M minus 4 times M plus 5. And again, it doesn't make any difference. This could be M plus 5 and this could be M minus 4. Doesn't make any difference. That's where they get a little bit sticky, is when you get these godless negative numbers in here. Let's see, how about this one? P squared plus 4p minus 5. Now, again, we want to take the factors of negative 5. And which two of the, now 5 is a prime number, so it has to be 1 and 5, right? Which two add up to, combine together to give us a positive 4? Negative 1 times 5, it's it there, isn't it? Or negative 5 times 1. 5 minus 1 is positive 4, so it's this one. Negative 5 times 1 is negative 4, so it's not that. Everybody see that? I don't think I'm explaining that real well. But anyway, we get p minus 1 times p plus 5. Okay. Now what if we have this one? Get this if you're so smart. Y squared minus 8y. If you're confused, just hang with me here. This is really pretty simple. It's just a different procedure. Let's see. Minus 8y plus 15. Okay, we take the factors of 15. Now, what are the factors of 15? 1 times 15. 3 times 5. That's all. Look, we can also, how else can you get a positive 15? Excuse me. Negative 1 times negative 15. No. Negative 3 times negative 5. Now, which two of these factors? This and this, this and this. Which two add together or combine together to give us negative 8? This one, right? So it's y minus 3 times y minus 5. Right. The times that you have to do the negative numbers also is if the linear term, the middle term, is negative. y squared is 6y squared minus 6y plus 8. Okay, our linear term's negative, so we're going to have to do negative numbers also. What are the factors of 8? 1 times 8, 2 times 4, 3, 4, that's all. And negative 1 times negative 8, and negative 2 times negative 4. Okay, again, when the linear term is negative, you have to do these also. Negative times a negative being a positive, right? Right. So it's negative 2 and negative 4, right? Give us negative 6. So y minus 2 times y minus 4. Right? Right. Mm-hmm. Okay. Here's one that's a little bit harder, but really not much. Squared minus 13x plus 36. Okay, again, our linear term, the middle term's negative, so we're going to have to use negative numbers also. Actually, that's really all we have to do. So what are the factors of 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9. I think that's all. Now, middle terms negative, so these are, and this is positive. So these are all going to be negative numbers. Okay, which two add up to 13? Negative 4, negative 9. So we get x minus 4 times x minus 9. Okay. Okay, let's do this one. A squared minus a minus 30. Everything in here is negative. So this is going to be, so what will give us negative 30? A plus times a minus. So we do, what are the factors of negative 30? Negative 1 times 30. Negative 2 times 15. Negative 3 times 10. Or negative 5 times 6. Okay. 6 minus 5 is 1, but we don't want 1, we want negative 1. We know it's going to be this, but instead of, it's going to be 5 times negative 6. 5 minus 6 is negative 1. That's our, get a plus 5 times a minus, minus 6. Starting to make more sense? Okay, now remember, this is only when coefficient, this is called the quadratic term. Again, not important, but you're going to hear that term from time to time. The quadratic term, when the coefficient, the number in front, is 1. We have a different thing to do when we have, when that's not 1. Okay, how about this? If we have squared minus 9x plus 20, okay? Okay. Again, here we want the factors of 20 combined together to give us -9. So we know that this is going to be a negative times a negative. So we get 20. -1 times -20. No. -2 times -10. -2 and -10 gives us -12. -3, -4 times -5. There it is there, isn't it? -4 and -5 is -9. These are our two factors. So it's going to be x minus 4 times x minus 5. You can do it backwards if you want, but really the only thing you need to do here is this. You add these two together, -4 and -5 is -9. That's right. And -4 times -5 is a positive 20. So we're correct. Probably. What if we have this? A squared plus a minus 6. Okay, for this to be negative, we're going to have a positive number times a negative number. So we want 6. -1 times 6, -2 times 3. Sit there, isn't it? That's also 1 times -6 and 2 times -3. These are also this. But when we add these two together, we add these two factors together, 3 minus 2 is 1. So we have a minus 2 times a plus 3. And again, if you'll do -2 times 3, -2 plus 3 is 1. That's that. And -2 times 3 is -6. So we're probably correct. Okay. Everybody okay? Am I going too fast? Please tell me if I'm going too fast. Y'all are making me waste all this paper. I'll tell you what, I don't think it's real good to do too much of this at one time. If anybody wants me to do more of these, let me know. Otherwise, we're going to stop.